Welcome back to the final video on the Sony Ta-4650 V-FET amplifier. This is the final review video after all the restoration videos that we've done before moving on to other projects. I've decided to split this video into 4 separate parts. Part 1 is just my subjective listening experiences over the last, I think it's been about 4 weeks. I know I said I'd get this out earlier, but I've noticed some things that listening to it, I wanted to sort of try to understand this thing a bit more because this is my first experience with a V-FET amplifier and I needed more time to get to know it. Part 2 will be analytical measurements. So we're going to put this on the distortion analyzer. We will see how much power this thing puts out. We will measure its distortion. We'll have a look at it as like just a power amp and an integrated with the preamp, 2 separate parts. Part 3, just answering some questions. A lot of people want to know why I restored this thing to the lengths I did. Questions around the restore process in general, parts, etc. And in part 4, we'll go over some of the tools that we used. I had quite a few questions about tools and just things I use for my restorations, and I'll try to cover some of that off for anyone who wants to know. So let's get started on this video, and we'll start with my general opinion of this amplifier. So after spending 4 weeks with this amplifier, what can I say about it really? Well, it definitely does have a sound that separates it from my other solid state amplifiers. I would describe it as warmer, just sort of more rounded and maybe a bit softer overall. Some people would say it sounds a bit more musical, I guess, but it's interesting because if I use it purely as a power amp and bypass the preamp, some of that does go away and it becomes a bit more neutral. So the sound that this thing has is not just the V-FET. Some of it is coming from the preamp section itself. But yeah, it does have a different sound, and I used it on three different types of outputs. I used my large floor standing speakers. I used my Klipsch HP3 headphones, which are 25 ohms. I've described these quite a few times. They are very, very sensitive. I will normally run these with a switch box connected to this and another amplifier. I'll mix the inputs up so I don't know which one is which. That removes my confirmation bias and the placebo effect because I don't know which one I'm listening to at any time. I also use my electrostat ear speakers, which go directly to the speaker outputs of the amplifier through these Lundell transformers and then into my electrostat ear speakers. These are Stax L700s. I use these for most of my listening because I control the listening environment. They're not in a room where I'm constantly moving things around with my floor standing speakers. You know, that's the same listening environment every time I put these on my head, and they are very intricate, very fast, and I get a very, very good impression of what I am listening to. The one bugbear I will say with this that became apparent very quickly is it does have a noise floor. Even after replacing almost every transistor in this amplifier, it still has noise floor. There are some JFETs that I left behind and haven't been replaced. If they're responsible, I'm not sure. I don't think it is. I'm pretty sure it's coming from the volume pot or the signal path just in general. My Klipsch HP3s can pick up that noise floor because they are very, very sensitive, and it is very apparent and it is distracting, I will say. When it's at like half volume, this noise floor does disappear quite a bit and then it starts to come back once you pass halfway. Why that happens, I'm not exactly sure, but it's an interesting thing anyway. With my electrostats, it's not as apparent because they don't have as much sensitivity and you can get away with it, and I can really enjoy this thing as a whole with my electrostats. But with the Klipsch HP3s, it's too noisy as an amplifier as a whole. If you're just using the power amp section, bypassing the preamp, it's very clean. And I can use these headphones perfectly with it. All the noise is isolated to the preamp section. I know that for sure. So you can bypass it, but you need to keep in mind you are taking away some of that sound signature when you remove the preamp from the equation. I love the tone controls overall. They're really nice to operate. They feel really nice. The detents are really nice. I'm a big fan of the loudness button. Everyone thinks loudness is the same between every amplifier. It isn't. This one is definitely just got a little bit more to it that I really love. It gives the music more body. It really brings out some of those intricate details in music that can get lost. Just really brings up that detail. I'm quite a fan of the loudness control, actually. I did try out some of the other tone controls. If you turn on the high pass filter, it does cut out a lot of that noise floor, but you're obviously losing a lot of other audio information if you do that also, so you need to keep it in mind. I also do like this detent that's built into the volume as well, so you can set a soft limit. You can just push past it but it will sort of stop there, which is great for setting like a max volume. We'll also say that this thing definitely has more than 30 watts per channel, which is its rating, because it's driving these electrostats, which typically with these transformers need at least 50, 60 watts per channel to go reasonably loud. And this thing was doing that pretty well. So I know this thing has more than 30 watts per channel in it. That's my listening opinion of this amplifier. Let's test it on the analyzer and see how much power and its distortion it actually puts down. All right, so I've got it set up on the Shibasoku audio analyzer going into my 8 ohm load bank, and we're going to run through some measurements. I will show you all this on a chart at the end, which was done with the lights off in a better environment, because the lights add electrical noise. There's a lot of other stuff going on when I'm filming. So it won't be an exact match what we're seeing now, but it's close enough. So at the moment we're at 1 watt and we're at 0.04%. And we can also check the other channel to see how close they're running, and we're at 0.05. And that's pretty close. There's not too much deviation there. We'll run this up to, let's say, 10 watts. This amp definitely likes a hotter input signal. I find there's a reasonable drop in distortion with a stronger input signal, so that's worth keeping in mind. So now we're down to 0.03 at 10 watts. 0.03, almost a perfect match across the channels also. Let's take it up to its rated power output, which is 30 watts. So that's 30 watts there. And we're at 0.04% and 0.04% on both channels. So that beats its rated specification, but I can also tell you that we are not near its power limit yet. So let's keep going. There's 40 watts, 50 watts. Distortion's starting to come up, but still reasonable. 55 watts, and it's gone. So yeah, that's too much. So in my previous testing, I found that about 55 watts seemed to be its upper limit. Yeah, around the 55 watt mark, you're still running 0.08% and 0.07%. So what I'm going to do is I'm going to switch it over now to the Power Amp Direct, and then I'll show you what this thing does without the preamp connected. Right, so hooked up directly to the power amp. This is as clean as this will get. So we're at 1 watt at the moment, and we're looking at 0.016%. On the other channel, 0.017%. Cool. All right, so we'll go through it again. We'll go up to 10 watts. It's a little bit more tricky doing it this way because I've got to crank it up with buttons instead. So we're looking at 0.013 and 0.012%. That's at 10 watts. Go up to rated power, around 30 watts. I'll turn that down a little bit. And 0.025%. On the other channel, 0.022%. So a bit of a difference, not too much. Yeah, so 55 watts at 0.06% is its absolute limit by the looks of it. So that's it for the measurements on this one. Its power output was well above its rating. It did, 55 watts a channel versus the 30 watts a channel it's rated for. Let's say 50 watts a channel, so it's not on the bleeding edge of clipping, but that's still almost double its rating, and it's a very, very impressive power output for an entry-level V-FET amplifier of this size. Put over the chart of all the measurements, and I will just say that yes, if you want the absolute best measuring amplifier, you need to bypass the preamp on this. That'll get you down into the 0.01, 0.02% distortion range, and it is at least double, maybe even quadruple better distortion performance. Not that you can hear it anyway in reality, but it does get rid of the noise floor also, and you can have the most pure V-FET experience in regards to this thing. But overall, you know, this is what it can do when you basically rebuild it from the ground up. So just covering off some questions that were left in the previous video. Some people were asking where they can find the service bulletins and the schematics for this amplifier. It's all available on Hi-Fi Engine. All you need to do is open up Google, put in the model number, put in service manual, and Hi-Fi Engine will probably be one of the first results that you'll get. I can't download documents from Hi-Fi Engine and reshare them again. That's just not right. There's probably other websites that have them listed as well. Just put it into Google. Google is your friend. You'll find pretty much everything you're looking for there. People were asking, can I share the parts that went into this unit? Yes, I can. Here's a spreadsheet of everything that I used. Well, that's in regards to capacitors and transistors. The resistors aren't in there because the service manual was accurate, so I just went through and itemized them based on what was in the service manual. So there were no issues there, and that is what I used in regards to this amplifier. There are a couple of just random comments from people, and I get this all the time, around like, what was the point of restoring it to this level because there's nothing left of the original amplifier anymore. My response to that is, hello, amplifier is still here, still has the original V-FETs. I can run it to maximum power and nothing went wrong. So yes, the original amplifier is still here. All the silicon has been changed, the capacitors have been changed, some resistors have been changed, yes. The components that went in there were better than what came out of it. So overall, it is a win. And this amplifier will stand the test of time, and people will be able to enjoy the sound of V-FETs long into the future. Yes, with some 70s and 80s amplifiers, you can just roll the dice, change minimal amount of components, and hope it keeps working. And sometimes you'll get away with it, sometimes you won't. Sometimes the amplifier will come back in 6 months with another problem and probably blow the outputs, or something else will go wrong. And in regards to V-FET amplifiers, you cannot take the risk with them. If the V-FETs die, the amplifier is basically worthy of going in the dumpster or being parted out. So I am not willing to take that risk, because the V-FETs, like I've said before, you're not going to replace them. And a few people have said you can convert them to MOSFETs. Yeah, sure, you could probably convert this thing to MOSFETs. You could also go and grab a pig and put lipstick on it. So what's the point? Just fix it properly, do the job properly, and then you can get another 50 years out of this unit. People seem to forget that 70s is a long time ago now. And we used to just recap amplifiers, and now we're changing transistors as well. What's another 10 years going to do? Who the hell knows what's going to start breaking once these things approach the 60-year mark? You know, like, it's a lot of time. And the fact that these things are still working after 50 years is just astonishing in itself. So yeah, that's pretty much all the comments. I will restore amplifiers how I want to restore them, and that is why I don't do paid work, because there are too many tight asses out there who want you to do the bare minimum, and then when the amplifier fails, they'll bring it back to you and point the finger at you. So yeah, this project for me was to see how far I can go with modern technology to bring this thing back to a modern standard. Right, so just before we close the video out, I had a lot of questions about the tools I'm using, which was unusual, but I'm happy to go through everything that I sort of use for this project in case anyone was curious. A lot of questions about the Thermaltronics soldering station I have. So this is the TMT 9000. This is probably the best purchase I ever made in regards to electronics work. So this is what is known as an inductive soldering station. Before this, I had just your normal heating element type soldering stations. This uses inductive soldering tips, or Curie tips, which basically just long rods that load in. There is no temperature adjustment for this soldering station. The tips set the temperature. It has a very, very fast heat up and recovery time. You can basically stick this on a large piece of metal and it will pump heat into it faster than the metal can absorb the heat. I can solder onto large metal chassis really easily with this thing. It reacts really fast. There's no more of that garbage of the old days where you had to turn up the temperature to melt like really large solder pads or whatever. This thing will just dump heat in really fast before you end up cooking the components that you're trying to solder. So yeah, inductive soldering stations, if you don't have one, spend the money on them. They are worth it. You'll never ever look back. They are expensive. I think when I got this, I paid about $400 for it, but that was over a decade ago now, and it's still here. I've replaced the tip once, and that's all the maintenance I've ever done with it. And I've got some other tips here in different sizes as well. It's a great piece of equipment. I've got my famous solder sucker that everyone tells me to get rid of and buy a desoldering station. I'm still using it. This thing's over a decade old as well. All original, haven't changed anything in it. Still does the job. I should have a desoldering station, I know, but I just haven't spent the money. You can get a desoldering station that plugs into the second output on here, but it's about another $700 investment in this day and age, and I haven't brought up the money to fund something like that. Maybe in the future one day I will do it. Anyway, moving on. I've got a capacitor tester here. I always use this on the fly for testing capacitors I'm pulling out of amplifiers to see the overall health of how the amp was looking as I rebuild it. Definitely make sure you've got one of these. Doesn't have to be this one, but you want some sort of a capacitor tester. Your multimeter is not a substitute for an ESR tester. You do need one of these things. I also have the peak transistor tester. This was quite important for this particular restoration, for gain matching the transistors that went in to replace it, for testing what came out of it, and just you can also use it for testing Zener diodes, normal diodes, everything else. Really great tool to have. Not the cheapest, but you can buy them in kits and they come up for sale quite often also. Calipers. You always want a set of calipers for measuring lead diameter, for measuring holders, things like that. When I'm 3D printing, this is the #1 tool that I use when I'm redesigning replacement parts, because you can quickly take measurements of things and recreate them in whatever 3D design software you're using to make substitutes. So yeah, these are Mitutoyos. They are definitely worth buying if you can afford them. Just do not buy cheap ones because they will be fake. This is a genuine pair of Mitutoyo. I think these, 200mm, really nice investment also. Moving on, my Metrics multimeter. This is a love-hate relationship. I love the interface on this thing. I love how it has trend data. It's just a great piece of equipment overall. I don't like the power save. It's the only thing I don't like on it, when the screen keeps dimming all the time. But other than that, being able to measure frequency and all the other usual stuff, it is an invaluable tool. I absolutely love this thing. This is a really expensive multimeter in the multimeter space anyway. I think I paid about $1,000 for this thing. It's saved my ass many times and I love it. Right, deoxit. You can't live without deoxit. I hate a lot of things about deoxit, but these little bottles, I use these a lot. They're great for brushing on the wafers of pots, for just sort of coating connectors. The red is used for cleaning. The gold is used for putting a protective layer on when you've finished cleaning everything. So yeah, these little bottles are great. They're almost empty now after over a decade and due for replacement. So I really need to replace these. They come with brushes as well. You want the brushes for sure. They're great. We have some oil. I put some oil in some of the trim pots after I cleaned them. So yeah, that's a thing. It's always good to have some different oils. And a lot of people asked about this, what the grease was I used in all these switches on the front here down the bottom. And that was Super Lube. So I've got two different ones here. I've got the PTFE one, and this one's, so this is a 21014 and this is a 92003. They are different, but I used this little one when I was doing all the switches on the front, but you can also use different types as well. It's just what I had. I'm not saying that is what is required, but it is very good for plastic sliders. Also forgot to mention, a few people asked about the ultrasonic cleaner. So this is a Vevor 6.5 litre unit with a basket also. I actually got this to clean records and vinyl and whatnot, but yeah, can use it for cleaning PCBs, etc. I was using Ambersil ultrasonic cleaning fluid. This stuff's pretty expensive, so keep that in mind. Use it sparingly. And I was mixing that with some IPA isopropyl alcohol also, just to help dissolve the lacquer on the back of the PCBs. But you need to be careful with isopropyl alcohol because it is flammable, but it seems to be okay when you dilute it past a certain point also. But it does evaporate, so keep that in mind. So that's it. Hopefully that answered all the questions that people had. That is the end of this project. We have many projects coming up soon. I've actually, the last few weeks, been preparing some other projects that are coming up, so get ready for that. I'll probably take a week break or something, and then we'll get stuck into another basket case of an amplifier, and it's going to go beyond this one, that's for sure. Hope you enjoyed this video series on the Ta-4650. I hope it helps other people bring these things back to life and not make any mistakes in the restoration process. And yeah, it was a fun adventure, and I will see you in the next video.